So user stories, Epic is more for these like lightweight process like Agile, whereas requirements engineering is more for the heavyweight processes like a waterfall model. So we're going to also see how we can epic requirements using use case models. So use case models is part of use case diagrams are part of the UML diagram family. So we're going to see, we're going to look at a few of these different diagrams. So after the use case diagram sort of theory part, we're going to have a look at the case study to sort of help you better understand the use cases. So I don't know if you remember, but after week 2 or so, we had like a little summary slide of what we've done so far. So I wanted to do another one before we start looking at each of these life cycle phases individually. So far we've looked at different methodologies for developing software, pros and cons of each of them. There's no perfect methodology. They all depend on specific scenarios, and more than one can be used for one scenario as long as it is properly justified. We also looked at how we can improve the different processes in the software development lifecycle using frameworks such as CMMI. And I think you had enough of Agile. We had 2 weeks of lecture on Agile, the principal practices, pros and cons. You had a guest lecture. We talked a little bit more about Scrum, which is what you're going to be using in your project this semester. We also had almost entire lecture on Epic user stories and acceptance tests. I also shared the nautical case study. Did you go through it while you were writing yours? No? It's really good. It has a lot of information. So if you need to improve your user stories and epics, I would suggest you go through it. And we also talk about persona. So any questions on anything we've done so far before we start requirements engineering today? You have a question? Yeah, go ahead.
Yeah, just what's the next deliverable?
We're going to talk about that at the end of the class. Any question on these topics that we've covered so far? The when question you asked me, there is something called a schedule that has all the deliverables. So you will get the answer for the when there. So you have seen this picture where we talk about the different phases of the software development lifecycle. So with any software project, you first gather requirements, then you translate the requirements into design, then you code the design, and then you do quality assurance, including testing, and then you deploy and maintain the software. So starting today, we're going to go over each and every one of those, except coding. I'm not going to show you how to code. But we're going to go over requirements starting today, and the software design as well. We're going to do a little bit of software design. So you've also seen this slide, which I showed, I think, right after we had a look at this slide earlier on during the semester. So what is requirements engineering? It's basically gathering the features, the requirements for your project, as well as the constraints, meaning everything that is not functional, meaning what we usually know as the ELTs, meaning things ending with ELTs, usability. Yeah, I told you, I sometimes I can't remember what I was about to say, but we'll come to that. So performance, correctness, and things like that. And we also talk about that requirement should not specify the how, but only the what. If you remember the example of the cinema website where they were talking about implementing the carousel using a jQuery, you remember that? So that should not be part of a requirement or user story or API. So how do we go about gathering requirements for the project? There are multiple phases. The first one is, of course, meeting with the customer and gathering, asking them questions, getting to know what they want the system to be able to achieve. So at a very high level, what do the system stakeholders require or expect from the software? Now that you've had you have the high level features, you start fishing out for details. You ask them questions. okay, you ask for this feature, you ask for this page, how much, how many seconds do you want it to be displayed, or, what color do you want this to be, or, what database do you want to be in, so you start getting more information. So once you have the high-level requirements and you've been able to flesh out the details, you write it down, same like you've written your user stories, and in this case, it's functional requirements. You validate it, you just show it or give it to the a stakeholder and ask them to read what you've written and to see if you both are on the same page. Oftentimes, you would have interpreted things a certain way, not exactly what the customer wanted, so you get to resolve all these things, initially. There is FERPS, which is used, a technique of FERPS, which is used to categorize requirements. So the first one are the functional requirements, for instance. So these are just describing the task of the user, the software, or the product, the features. An example here is the search facility should allow the user to find a reservation based on last name and date. And then you have all this other stuff, like the non-functional requirements, also so-called soft goals, also called constraints in Agile. So these are the URPS, but actually there's more than just URPS. So for now, let's just go along with this. When we do software quality assurance, you'll see that there's a lot more of these EVPs, what we call in jargon, software engineering jargon as EVPs, just sort of the last part of the name. So these describe the properties of the system or the domain, and in Agile we were calling them constraints. For example, the response time shall be less than 1 second, so things like that. So what does FERPS stand for? The URPS. U stands for usability, meaning here we're talking about the different human factors, help, documentation, user manual. And R, we're talking about reliability, meaning, for instance, like frequency of failure, recoverability, and things like that. Performance, we're talking about things such as response time, throughput, accuracy, availability. And supportability, we're talking about how easy, for instance, once you've developed the software, is it to maintain and adapt the system. So this falls under the umbrella of supportability. And like I said, there's much more to it. So here, we talk about non-functional requirements as the non-functional requirements, soft goals, and constraints, and they are also called constraints as well, and pseudo requirements. So there's a lot of naming for different names for the non-functional requirements, but they more or less, all mean the same. On the next slide, I have some examples of functional requirements as they would be written in a project using methodologies such as waterfall. You see, you remember how you wrote your user stories into these 3 parts. They also have a specific way of writing requirements. So tell me if you notice anything. Just read a couple of them and then you can read the others on your own. Anybody notice anything? Do you see how they are written very formally, like shall? All of them have the word shall. User shall be able to, the user shall be able to search, the user shall be able to add a picture, the system shall provide appropriate viewers, etc. So this is basically how you write requirements, in heavyweight models. So if you are implementing a software using waterfall, this is basically the format in which your requirements are going to be written. So what is more interesting are these non-functional requirements. So read, have a look at them, and then we're going to go over them one at a time. For those who are late, I don't have COVID. It's just a bug that I got during So the first one is talking about availability. And you can see that, it's telling you when the system shall be available. And the second part, there's still that downtime within these hours, which is 8:30 and 7:30, shall not exceed 5 seconds in any one day. So the total amount of downtime you can have in one day is 5 seconds. So these are, constraints that the user has imposed on the system. So the second one is a little bit more interesting. So things like hospital management system or patient registration or any of these systems or which are mandated by governments and things like that. Sometimes they have to adhere to certain standards, rules, laws. So in this one, it says the system shall implement patient privacy provisions. So the way patient privacy has to be implemented in the system has to be according to that particular standard. So, when you're implementing the system, you have to follow these standards. The last one is regarding basically, how user-friendly the system is. So, the medical staff shall be able to use the system functions after 4 hours of training. So it's not that big of a deal. They are expected to use the system after some training. After the training, the average number of errors made by experienced user shall not exceed 2 per hour of system use. So they're already telling you, the number of errors should not be greater than this. So this is talking about all these aspects of, usability, user-friendliness of, using the system, how easy it is to learn. And I don't know what will happen if, for instance, the users are making more than 2 errors. Maybe there's a follow-up requirement that they have to be taken training, something like that. So, what are good requirements? So, there are many characteristics. So here are some examples. Your requirement should be clear. I think we talked a little bit about that when we were doing user stories. So requirement should be clear, should not be ambiguous. We should be able to verify and test them. So that's why as part of your user story deliverable, you also have to submit acceptance tests. If you cannot test your user stories, then how are you even going to implement them? How are you going to test them? Complete and a bunch of other of these sort of characteristic criteria. So the next 2 slides are really interesting. They provide example of unintended feature, and the other one is an ambiguous specification. So I'll leave you to read this. And this is a real story, by the way. You can Google it. Okay, so in this particular example, when the developers or testers was testing the software, they forgot one scenario. And this is pretty scary. Imagine being on this train, and the train, departing the station is on the driver. But this is something that actually happened because one scenario was missed during the testing. Read this one. Examples like this early on, differences in interpreting metrics. So when the developer was writing the requirement, they did not state what the 10,023, what was the metric for that. And by default, the computer interpreted it in miles when it should have in feet. So besides. So I'll leave you to read this one on your own. This actually depicts the requirement engineering process, and unfortunately it reflects a reality more often, than we would like. So this is what I've been telling you all along. The first picture, top left, is basically how the customer is going to explain it. And at the end of the waterfall model, for instance, and you give them, something like this. How was it? Something like this, but this is actually what they needed. So that's why you should validate your product as and when you go along. Make sure you and the stakeholder, customer, user, whatever you call them, are on the same page. So we know that for gathering requirements, this is something that you've already done. You've had to identify users, stakeholders of the system. You've had to identify the different features, epics, user stories, functionality, features, whatever you want to call it. And you've also had to identify, maybe unconsciously, the differences between the different features, meaning what features depend on the other. Although we didn't call it, we didn't call it relationships. We just said, okay, make sure we know which requirement or which functionality feature every user story is dependent on the other. But now that we are going to do, we are going a step further and looking at requirements from a UML perspective, from a use case perspective. These are the terms that you're going to be using. So you identify the different functionality, and then you sometimes you have the functionality at high level, and you have to break it. So think of a functionality as at high level as epics, and then breaking it down further into user stories. And the user story itself, when you're implementing it, it can have its own breakdown, like multiple smaller tasks make up a user story, and identify relationship between them. I need to do this first before I can do this, or this one depends on the other one. Or I have a bunch of different users of the system, I can extract the common user. And of course, identify the non-functional requirements, which is all the constraints and entities and the verbs, the herbs in verbs. How do we get requirements from a user? So I don't know how you guys did it, but probably you interviewed the person, you talk to them, and you try to fish out the requirements from them. So these are very popular techniques. You talk to the customer and ask them what you want the software to do. So interviews, surveys, sometimes you can have sort of a focus group. Sometimes you do observation, you actually go and see how the work is being done manually, especially if you have to automate it. Sometimes to get the requirements, because it's so complex, you use a prototype, a throwaway prototype. You still remember that? What is a throwaway prototype? Really? The word itself doesn't give it away? So just a piece of software which is basically, not doing anything useful, nothing is working, but just showing to the user, okay, this is how it's going to look like, this is where things are going to be placed, and sort of just validating the requirement, making sure you got everything right. And then normally it can either do two things. Either it can evolve into the final product, so you have this sort of evolutionary prototype, or it can be thrown away, meaning you've understood the requirement. So you can throw it away and start implementing the product from scratch. So this is another Dilbert that you can read. You should be familiar with this now, that customer doesn't even know what they want. So the third part is how to validate requirements. Using Agile, you've used a user acceptance test. So what we're concerned here is validating whatever we're giving the customer is what they really want. So, we have to examine and make sure everything is, nothing is ambiguous. You have detected and corrected any inconsistencies, omissions, errors, and it is conformed to, the standards established in the process, the product, or the project, and this is often going to be mandated by the customer. They're going to tell you this has to be up to this standard and according to this law and this, requirement, regulation, and so on. So we had a graph initially in the initial lectures showing that, when you got a bug early on, how cheaper it is compared to catching it, later in the life cycle. So when you catch a bug earlier on, it costs you 100 times less than actually fixing it later in the life cycle. And and these are here is just an example of one work, and how many bugs do we have in a software system. So we try to validate, make sure the requirement is okay before we move to the software design step. So I'm not going to go over this, but this question should help you validate your requirements. So remember, we are doing Agile. At any point in time, you can go back and modify it. It's not, of course, the day before the presentation deadline. You have to be reasonable, but right now, while we're doing the design, you have to modify certain stuff. You can go back and actually modify things. Not also probably when you're doing coding and say, hey, this is a simpler solution. Let's just wrap it up. I'm just going to simplify the requirements and to fit what I have. So don't cheat. So I'll leave you to read, how to validate your requirements. We talk about that. You manually verify validate your requirement with your customer. You can use prototyping, or you can also develop some tests for the requirements. And we did something similar for user acceptance tests. How do we prioritize our requirement? I don't know if you remember, but I told you, when you were writing your requirement, to just split it into two baskets. One are the requirements that your product will not be able to function without. Without this requirement, the product is useless. And the ones that are nice to have, but even if you don't get to it, nothing's going to happen. Your product is still going to be working. Well, I roughly told you to break it into sort of two parts, two sections, two baskets. But in this technique, more formal technique than what I told you, which is called the Pascal method for prioritizing requirement, you have some requirements which fall under the must basket, or some which fall under the should have, and some which fall under the could have, and some which fall under the won't have. So you can do a little bit of research. If you want to use this to prioritize a requirement, be my guest. But this is just one of the techniques. If you Google, for example, requirement prioritization, you're going to come across a bunch of different techniques for prioritizing requirements. So basically, with your stakeholders, this is not something you do, because you had a dream last night. You sit down with your customer and you ask them what's important for them, and you move it according to the basket. Okay, so the last part of requirement gathering is traceability. This might not be important for your project, which is quite small, but for larger projects, traceability is sometimes mandated by contracts and standards. For example, in military project, in aerospace project, you need to have a requirement traceability document, which basically can be any of the ones below or all of them, meaning source traceability. Who are the stakeholders to propose a requirement, meaning who proposed this requirement? So you trace the stakeholder to the requirements. Second one is requirement traceability. What requirement depends on what? So the relationship among requirements. The last one is design traceability, meaning mapping the requirements to the design of the software. So for example, we're going to do use case diagram today. You can say use case 1.1 it helps assess the impact of changes. So if we are changing requirement 1, what are the other requirements or what are the other artifacts that are going to be affected? So this doesn't stop here. You can also have test case traceability. These test cases, what are we testing? Which requirements are we testing? So one technique that is used to trace requirements is traceability metrics. And this is a very simplistic version. This has 8 requirements. In real projects, you have hundreds of requirements. This is much more complex. So you can use this if you want for your project to just sort of do a mapping. For example, if I'm changing 1.1, what is also being impacted? And as you can see here, 1.3 is being impacted. This is just an image I stole off Google Images, but you can define your own legend, like what does the different lettering mean. Here, U means uses the requirement, R means some other weaker relationship, but you can define your own. Questions before we move on to UML diagrams? Yeah.
So what is the difference between a use case and a scenario?
I didn't understand your question.
The difference between use cases and scenarios.
We're gonna, the next part of the lecture is use case and scenario. So any question on requirements engineering? Okay, so let's talk about UML diagrams. So UML stands for Unified Modeling Language. It was first released in 1997 by these 3 people, which are respected people in the software engineering community. So the purpose of the UML diagram was to provide the development community with something that was pretty standard. So, excuse me, that was rude. I'm so sorry. So to provide the development community with something which is equivalent, like blueprints of a building. When an architect look at the blueprints of a building versus another architect look at the same blueprint, because they are certain conventions that you have to follow, they all understand, right, what this little box means, what this arrow means, and so on. So they try to do something similar to software engineering. So when you represent the design of a software, multiple actually aspects, you can have a lot of diagrams that we're going to see on the next slide, the multiple viewpoint of the software. So they try to do something similar, that when software developers or designers, or whatever you want to call it, they look at these diagrams, they all are able to understand the same thing. They are all able to interpret things in the same way. So one thing, if you look at the bottom, one of the things that you'll have to submit as part of your next deliverable, I know it's not available yet, I'll talk to that. I'll talk about that a little bit later. One of the things that you have to do is use software to build any of the UML diagrams for the next deliverable. Don't use Microsoft, like word processing or PowerPoint, or I know some of you might be artists, but don't drop something, sketch something on paper. Use one of the tools that are freely available online. This, I list a few open source tools, but you can just use about anything that you want. So Google, some of the tools, some are paid, some are going to give you like a 7-day trial. So you probably want something that is free, not a 7-day trial. So most of these tools are drag and drop. So you'll see, for example, when you go to these tools, you'll be selecting a use case diagram, and you have all the different notations, and you can drag and drop and draw your own diagram. So yeah, make sure you use a proper tool for drawing things. Different types of UML diagrams, and they're grouped into categories. So the very first one is behavior diagram. So if you see on your right, there's a group of diagrams called behavior diagram. So behavior diagram basically depict the features, the epics of the system. So like what are the business cases, what are the business process, what are the features of the different of your product, the software you have. And different diagrams fall under this category. And we're going to look at a few of them. And you're going to be drawing a few of them as well for your deliverable. So the next one is interaction diagram. So as the name say, if you look a little bit at the bottom, you'll see 4 different types of interaction diagram. So So an interaction diagram, as the name says, it's basically shows you how different objects interact with each other. Like what are the different relationships among the different objects in your diagrams. And the last one on the left, you're going to see structure diagram. So diagrams that falls under these categories, they represent a snapshot of the system at any point in time, meaning irrespective of the time, they are always going to be the same. So these are the diagrams which falls under the category structure diagram. And I have a little bit of explanation here, basically what I just told you. It's exactly the same thing here. So use case diagram is one of the type of diagram that you're going to be implementing or designing as part of your next deliverable. So a use case, what is a use case? So it's just a unit of functionality provided by the system. A use case can be high level, can be low level. At high level, a use case can represent the different functionality of the system. At low level, you can have the functionality of the feature or epic, whatever you want to call it, broken down further. So you get a low level use case. Part of your question is answered? Okay, we're going to come to the other one as well. So why do we need a use case diagram? Shows you what functions are provided by the system, what are the stakeholders, what are the actors that are involved in this particular use case. It shows you the interactions among the different objects in the system. So like I said, it can be different level. It can be high level or it can be low level. So probably for the next deliverable, you will have to submit a low level use case. But in order to be able to provide or design a low level use case, you have to know at high level what are your different use cases, so you are able to break one of them into smaller pieces. So we talk about actors and scenarios and we talk about use cases. So these are basically what make up a use case diagram. So one of the things that make up a use case diagram is a system boundary. So this is just your UML diagram, your use case inside a box, as simple as that. It is optional, so when you're dealing with external system, some designers like to put what is in scope within the box. So it clearly defines that, hey, we're just implementing this. What is outside the box is not in scope. So if in your project you're interacting with things that you're not implementing or things that are out of scope, it might be useful to have a box. So to sort of delineate between what you are actually implementing and what is you are not implementing. So a scenario, to answer your question, is basically a sequence of these actions and interactions between these actors and the system. So you break the use cases into actual tasks. This is basically what is a scenario. And we're going to see examples as we go along. So questions commonly answered by a use case. So when you're designing a use case, you will be asking yourself these questions, right? Who are the actors involved in this use case diagram? What are the goals? What are the features that I'm trying to design here? What are the preconditions before being able to do a search? Does the user need to be logged in the system? What happened after the search? So what are the preconditions? What are the post conditions? So these are just a brief example that I gave you. Of course, yours is going to depend on your actual scenario. What are some exceptions, or what are some variations? For example, you can pay with a card, you can pay with cash. So these are different variations of the system. So again, this is all good, but better illustrated with an example. So we're going to look at an example of an ATM, and we're actually going to go through how we will design a use case diagram. So I'll give you, yes, questions? I hear some murmuring. No? Okay, so I'll give you a minute to read this. This is a very simplified version of an ATM, so it doesn't have all the scenarios, and we'll just focus on these four the case study. have an ATM that offers the following service, so distribution of money, so you put in a card and you get some cash out, and then you can check your account balance, you can deposit cash, deposit check, for those who hold card from the bank. One thing not to forget is that all these transactions should be secure, and sometimes it will be necessary to refill the ATM machines. So again, this is a very simplified version. So let's try to break it down, how you would actually draw your own use case diagram. So first you will think about the different actors. So here, to be able to identify these actors, you have to talk to customers who are going to be your users of the system, or who are we going to interact with, who the system is going to interact with. So how do we represent actors in UML diagrams, in use case diagrams? It's actually these little stick figures, and you will see when you download a tool, you will see these little stick figures that you can drag and drop. Of course, it's going to have the word actor below it, and you have to change it to how your actors actually form. In our scenario, these are the following actors. So we have some actors which are more primary actors, meaning they are directly sort of concerned with the system. You would have the customer, you would have the bank holder. In a minute, we're going to see what is the difference between these two. And you're going to have the maintenance operator, the person who refills and take out, retrieve cards, and etc. from the ATM machine. And then you have these external stakeholders. For example, the bank is going to be working with operators such as Visa, MasterCard, and all these authorities and organizations and things like that. So they are not part of the use case, but we will need to interact with them. So if I had to draw a system boundary, these two guys will be outside, meaning the Visa authorization system, and also the information system of the bank. It might be part of the bank, but for example, a management information system in MIS might not be in scope of what I'm implementing. So these will be outside the box. So once you have identified your actors, now let's identify the use cases. So this is the list of use cases for each of the actors. So a cardholder can only do one thing, they can only withdraw money, whereas a customer, they can do multiple things. They can withdraw money, they can consult balance, they can deposit cash, they can deposit checks. The maintenance operator can refill the dispenser, retrieve cards that have been swallowed, retrieve checks that have been deposited, and so on. And because the last two actors are not part of the system, as you can see, I don't have any use cases for them. So as you're going to see in the next few slides, you're going to have multiple versions of your use case diagram. So the very first one can be very simplistic. You're trying to draw some random boxes, some random actors, and then as you understand your requirement better, you can actually flesh it out, or modify stuff, or add stuff, or break down. Maybe once you, for example, withdraw money. This is just a simple example. Withdraw money, and when you actually discuss and brainstorm as a group, you find that it's too big to be just one use case, and you have to break it down into multiple use cases. So you're going to do that. So here you can see the boundary box, and you can see that, well, actually these actors should be part of the system. The boundary box should actually be bigger, because maintenance operator, cardholder, and bank customer should actually be part of the system. Things that are not part of the system would be the Visa authorization system and bank information system. So you're going to be looking at different books, even the books that I provided, the library provided free of charge. These diagrams, you're going to see multiple different versions. So sometimes, like this is taken from a book, as you can see, the actors are outside. I would personally put the actors that are outside the system boundary as actually outside, and I would put those in. So then you have these little ellipses or ovals. These are the use cases, and then they are linked. They are linked by these associations, these lines, to the primary actors, which is these little sort of stick figures. So this is a first version. So you have the lines and you have the ellipses, you have the actors. So one thing to remember, can you see that some of the lines are touching the ellipses, some of the lines are not touching the ellipses? So again, that doesn't matter. If you want to, be perfect and make it sort of fall right in the middle of the ellipses, you do you. I'm not gonna, we're not gonna judge you on that. But different books, this is taken from a book. Different books are gonna, either be very cautious about this sort of things or be sort of very messy. So this is the first version of the use case diagram. So the second version of the use case diagram, I want you to look at the card holder and the bank customer. So let's step back. Do you see that the card holder and the bank customer have withdrawn money in common? Does that remind you of anything in object-oriented programming? Yes.
Superclasses.
Yeah, superclasses, child classes, inheritance. So we actually have the same notion. So in the second version of the use case diagram, we are actually going to have sort of an inheritance relationship, meaning, the bank customer, which is the one which can do much more thing, is going to be sort of a child classes of the cardholder, which is the sort of parent class. So you have to identify all of that. So if you have multiple stakeholders, you have to ask yourself, are there any more relationship here? Can I do classes, inheritance, or super classes or super actors, whatever you want to call it? You can sort of withdraw things, specialized things, like sort of an inheritance relationship among the actors. So for me, if I were to draw this thing, I would have my third version, but I would actually put the Visa AS and the Bank AS outside the box. So here they even remove, the box. So you can draw the system boundary just to sort of delineate what is actually inside the system and outside. So there are more relationships. Generalization is not only one of them. You also have what we call extents, as in the first figure. So what does extend mean? It's basically a use case adding more functionality, to the what we call the base use case. So the arrow is normally from the extension use case to the base use case. If we look at this example, there is a registrar, and then there are two use cases: distributing information to students and distributing schedule information to students. So more generally, I would say I'm distributing information to students. But to be more precise, I am distributing schedule information to students. So in similar way, you can extend your sort of base use case to have multiple of these extension use case. And look at the direction of the arrow. It's from the extension use case to the base use case. So the other one, figure 2, represent the users or include. So you can have, what you actually see on the arrow. In some books, it's going to be called include. Meaning to be able to do one, you have to also do the other. So the example of the cashier, when you're checking out items, at the point of sale, one of the things that you have to do is scan the item, right? So that means that checkout items include the swiping the barcode or UPC code for the item. So when you're building your use cases, so look out for these sort of relationships. There are also textual description, textual representations for use cases. You might not need it for your project, but for sort of more, sort of serious systems, life-critical systems where they want to be able to describe everything in a lot of detail, so they will be using these sort of templates. Just for illustration purposes, I'm going to use a template to illustrate how we would represent the use cases in the case study that we are looking at textually. So I'm going to take one use case scenario, which is withdrawing money using a Visa card. So normally you would have a table like this, and you have summary and like a bunch of different who is actually like who are the actors, when was the use case created. A little bit like when you write code, you put some stuff at the top, like with the author and name and things like that. So you put some information about who's actually designing that use case. And then you will have the flow of events. So what actually does withdraw money using a Visa card consist of? What is actually the flow of events? Now I'm actually feeling very hot. I'm so sorry, guys. So the flow of events, so sometimes, like I mentioned, you'll have to, you need some precondition, meaning you won't be able to start with the actual actions before you do something. For example, if you, when you're logging into your bank account online, you have to log, when you want to check your bank balance, you have to log in first. So that's sort of a prerequisite precondition. So similarly, before you withdraw money, there are certain conditions, preconditions. You need to have money in the ATM, and there's no card in the reader. Of course, that's going to vary according to your particular project. So once you have listed all these preconditions of that specific use case, then you start what you call your main success scenario. Meaning if everything goes right when you're withdrawing money, this is exactly the sequence of steps that would happen. I'll give you a minute to read that. There's quite a few here. Done? So this is a scenario which, when you are withdrawing money, if everything goes according to plan. I'm guessing you've withdrawn money at some point in your life. Okay, so this is sort of the perfect scenario. So another way of representing it is sort of classifying it according to the stakeholders. If you see one of the columns is just the card holder, and the next column is the ATM. So you can also sort of break it into these two columns. Unfortunately, not everything goes according to plan, and when you are writing your use case, you have to think about all these alternative scenarios. Meaning, for example, what if I have entered an incorrect PIN? So then, for example, this alternative sequence have incorrect PIN entered. So then what happened, this sequence, you give it a rough sort of reference number, A1 is temporarily incorrect PIN number. So A1 sequence starts at 0.5 in the main success scenario. So if we go back, so that means step 5, the ATM compares the PIN with the one that is stored on the chip of the card. And if this is wrong, so then you have this sort of kicks in that scenario. So what's going to happen? The ATM is going to inform the person that the PIN is incorrect, either first time or second time, etc. And it's going to record that there is a failure, in this transaction. And what happened after that, if you fail to enter your PIN, it goes back to 0.3 in the scenario, meaning it goes back to when the ATM asks you to enter your PIN. So this is one alternate scenario. Another one is what happened if the amount requested is greater than the daily withdrawal limit. You know that with all cards you can only retrieve a maximum of X amount daily. So this one starts at 0.10 in the success scenario. So let's go back and look at 0.10. The ATM checks the desired amount against the daily balance. So if you want to withdraw more, then the ATM is going to display a message that you're trying to request an amount which is more than what you allow, and the scenario goes back to point A, which is the ATM asks you to re-enter the amount. So similarly, there are other scenarios. So this one is A3. The customer does not, or cardholder does not want to receive. So what happened? It returns back to point 11, and as a result, the cardholder declines to receive. The ATM is just going to return the card. The cardholder takes the card. The ATM issues the banknotes, and the Visa cardholder takes the money. So these are some examples of alternate sequences, meaning it's not wrong, but there's also something that can happen in addition to the main success scenario. Now there's a different type of scenario, which is called error sequences, error scenario. So this one starts at point 2. What if you have an invalid card when you're trying to withdraw money? Because this is the scenario we're talking about. So what's going to happen in this case? The ATM is going to inform the cardholder that the smart card is not valid, either it's expired or unreadable, etc., and confiscates it. So now, before you you tell me that's not what happened, confiscates it or not confiscates it, this is not something that you and I made up. It's what the customer wanted. So if the customer says if the smart card is not valid, the ATM should confiscate it, you have no say in that. This is basically how you should implement the system. And normally, when you have an error sequence, the use case fails. You can't go any further, meaning you are at point 2. After point 2, when the card is verified, you don't even get to step 16 because the whole scenario fails. The next one is incorrect PIN number. So you have a number of tries when you enter a PIN. So let's say you've entered the PIN wrong 3 times. So the ATM is going to inform you that the PIN isn't correct for the 3rd time. And again, that's what it's supposed to do. It's going to confiscate the card. It's going to write a notification, that the system, the transaction failed. And of course, the use case is going to fail. Another error scenario is unauthorized withdrawal, meaning the Visa authorization forbids any withdrawal for whatever reason. Maybe the card is stolen or something like that. So the Visa authorization, when it's time to sort of validate the transaction, they're going to restrict it. They're going to forbid the transaction from being successful. So what happened in this case is the card is going to be ejected, and again the use case is going to fail. The next one is what happened if the card is not taken back by the cardholder. So after 15 seconds, for instance, the ATM is going to confiscate or swallow the card. So if you look at this, you can see that it's clearly written after 15 seconds. And normally, you would have to fish out these sort of details from the customer. Because if you were to write the software for this ATM, you wouldn't know how long you have to display the card. The card has to be sort of out of the ATM before it swallows it. So this is sort of a non-functional requirement here we're talking about. So again, the Visa authorization system is notified and the use case failed. Last one, which is unlikely, but it has happened, you don't take your money. So what's going to happen in this case if you leave the person who's behind you in line might take your money? Or the ATM, there's nobody after 30 seconds, the ATM takes back the money. And of course, the Visa authorization is a system informed and the use case fails. So you can come back and get your money out of it. So for your use case, think about all these different sort of alternative scenarios, error sequences. So what is the post-condition of this particular use case, which is withdraw money? So the precondition was the ATM has money and there's no card in the reader for you to be able to actually do the transaction, which is withdraw money. So the post-condition is this. The ATM has less money than before the withdrawal. So as simple as that. So I told you we're going to finish a little bit earlier today. So what's next? I know I haven't made the deliverable 4 available yet because we haven't covered anything until today. We've just covered UML diagrams. So, I told your tutorial, your TAs, to have you work on some higher level stuff this week. So other than when we start going over these diagrams, like after today, you should be able to start designing your use case diagram. Even though it is sort of very rough and, like it's gonna be refined, but at least you can design a high level use case and decide which one are we going to implement as part of the deliverables. So for the bonus assignment, the mixer is due September 30. So I just corrected this on the slide, September 3. That's not right. I made a typo when writing this. Anyway, all of the assignment deadlines and everything is on Canvas, so don't rely on the last slide. This is just sort of a summary. All the schedule, everything is updated. So that means that for those doing the bonus assignment, you will have to meet with potential 470 members, sort of see if you're compatible, and then once you select each other, it's not a forced relationship, so you have to really work with each other, then, you start dating. So you have a spreadsheet to fill. You have to select what teams you're going to be interviewing, and there are little boxes in a spreadsheet, and then when the sort of relationship is finalized, you both agree to work with each other, you add the name of the person that you're working with. There, unfortunately, only 5 teams, there is only 470 members, so some of you will not be able to proceed with the bonus assignment. So let me complete this and then I'm going to answer questions. So the software design deliverables is not due until 3 weeks from now. So in the meantime, you can start working on the UML diagram and starting today on your use case diagram. There are reading assignments for the next few weeks. This is not for next week. So the whole software design is going to take a few weeks. There's a lot to cover in software design. It's one of the most important part of software implementation, actually. If you get the design right, everything sort of falls in place. There are some optional reading as well. So next lecture on Thursday, review this lecture because you're actually going to be drawing a use case diagram in class. So we're going to be doing an exercise. So review this lecture, and then next lecture, after the exercise, we're going to dig deeper into software design, like properly start software design, and we are also going to talk about interactive diagrams, so how do you design interfaces and things like that. Somebody had a question. Yeah?
Yeah, for the bonus assignments, I'm not exactly clear whether there's like an event servicing happening on the 30th or whether we're supposed to contact them tomorrow before the 30th.
So can you open the bonus assignment? There are some instructions at the top of the spreadsheet and in the assignment description, which says that you're supposed to meet the people, and then the 30th is when you're supposed to actually finalize the name of the people. So it's written multiple places, the bonus assignment description and the spreadsheet that you're supposed to fill. Any other questions? Yeah.
By now, we should start doing batch recording.
You can start coding. Once you have your requirement, like I told you a couple of weeks ago, sorry, you can actually start coding your